we're going to continue with AP review. This is 2010 BC free response number 5. Consider the differential equation dy dx equals 1 minus y. Let y equals f of x be the particular solution to this differential equation with the initial condition f of 1 equals 0. For this particular solution, f of x is less than 1 for all values of x. All right, part A. Use Euler's method starting at x equals 1 with 2 steps of equal size to approximate f of 0. Ooh, fun, so we're working backwards. Show the work that leads to your answer. Okay, so I like to do Euler's method with a table. You don't have to be that person, but that's how I roll. So when I do Euler's method with a table, right, I put my x value, and I know I'm starting at x is 1, right, and then I'm supposed to go in 2 steps, so and I'm supposed to work my way back to 0, right, so 0.5 and then 0, right, and then I do know what f of 1 is. It's 0, right. I have my slope, which is just dy dx, so my slope is 1 minus y, right? And then to find my new y, right, I'm going to do the slope times my change in x, which we'll talk about in a sec, plus the old y, right, plus y old, right, so the y that I got here. So for the record, and again, this is the way I do Euler's, you don't have to do it, but this is just point slope, right? Y minus the y value equals m x minus the x value. If you move that y 1 over, you get y equals m x minus the x value plus the old y, right? So you could totally call this x minus the x value your delta x, which is exactly what's there, and the y1 is my known y value, right? Sorry, sliding that over. The y1 is my known y value, right? So this is just point slope. I like this about Euler's method because this way I never forget it. If I try and remember it with a lot of fancy notations, it's harder for my brain, so why not use existing knowledge to do stuff? So anyway, it's worth noting that in this case, right, my change in x is a negative 0.5, right, because I'm going from 1 to 0.5, which is back 0.5. So if you want, you can go ahead and change that delta x in your formula to a negative 0.5, right? That's delta x, but that's worth changing to a negative 0.5. All right, cool. So let's walk through Euler's method. So my slope, right, in this case, my slope is going to be 1 minus the y value, which is 1, right? 1 minus 0 is 1. So, and my new y, right, the new y that's going to get transferred to the next line is my slope times the negative 0.5 plus the old y, which was 0. So I think I just get a negative 0.5, right? Negative 0.5 plus 0, so I put a negative 0.5 here. And then my slope, right, is a 1 minus a y, so that's 1 minus a negative 0.5, which would be a 1.5, right? And so my new y should be a 1.5 times a negative 0.5 plus this negative 0.5, right? And there's a couple ways you can deal with this. I get that maybe it's not our favorite thing in the world to multiply decimals, and that's totally fine. You have some options. You could turn them to fractions. Honestly, you could factor out a GCF of negative 0.5 right here because they both have it. It's up to you, and I'm going to give myself a little bit more room to work here because I don't really, this is my final answer, right, is the y value at 0. So if you want to make this a 3/2 times a negative 1/2 minus a 1/2, that's doable, right? You'd get negative 3/4 plus, well, sorry, my bad, minus a 2/4, right? And you'd get negative 5/4, and that's fine. If you'd done it a different direction, right? If you'd gone with decimals instead, you might have made this a negative 0.75 and a negative 0.5, and you would have gotten a negative 1.25, and hey, look, it's the same answer, right? So either way you do it, f of 0 is approximately negative 5/4 or negative 1.25, doesn't matter which one. Again, Euler's looks really different depending on who does Euler's with you. I do mine as a table, and I do mine as essentially just point slope, because really it makes it an Algebra 1 skill, even though it's technically a much higher level skill. All right, cool. Moving on. Part B. Also, this is worth 2 points. 1 point for Euler's with 2 steps, and 1 point for the answer, meaning they do you the solid of realizing that sometimes we all add or multiply wrong when we do Euler's on a non-calculator question. But again, it stinks to lose the point for adding or multiplying wrong, so try to be careful on these. Almost every Euler's question boils down to that. Okay, cool. Part B. Find the limit as x approaches 1 of f of x over x cubed minus 1. Show the work that leads to your answer. Cool. So, gonna erase my Euler's work. All right, so part B asks for the limit as x approaches 1 of f of x on top of x cubed minus 1, right? Well, we already know, so we could try and plug in first, right? There's nothing wrong with trying to plug in, and you get f of 1 over 1 minus 1, but you get 0 over 0, which is literally never the answer, right? It's never the answer because this is an indeterminate form. right? Indeterminate form, sorry. Okay, so this is cue to do L'Hopital's, right? I like to make L'Hopital's a verb, right? You are clear to L'Hopital. So what that means is that I can apply L'Hopital's and derive the top over the derivative of the bottom. Cool. Well, now I get that this is f prime of 1 over what seems to be a 3 times 1. Well, it's definitely not 0 over 0, right? So at this point, I can actually go ahead and find the value, right? So the question is, what is f prime at 1, right? Well, we know, right, that when x is 1, right, we know that when x is 1, y is 0, right? Cool? Hopefully? Okay, so because they gave us this point, 1 comma 0, right? The problem is that I want to, so this y, like f prime of 1, means I need to evaluate my dy dx at the point 1 comma 0. Well, the reason it's relevant that it's at 1 comma 0 is because there is no x in my dy dx formula, so I can't plug in a 1 here because like 1 is the x value, and if I plug in a 1 here, I'm plugging in 1 for y. So I'm going to get that this is a 1 minus 0. So what happens, right, is I'm going to get that this, sorry, that was kind of a hot mess, hold on, that this whole thing is a 1/3, right? So the trick here is I think a lot of people accidentally get 0 because they get to f prime of 1 correctly, and then they think, oh, I should plug in 1 to my derivative, but you shouldn't because you're not plugging in, like the 1 is the x, not the y. And again, the way I was able to know the y is I only know one y value in this whole problem. The only y value I know is f of 1 is 0, which means if x is 1, I know the y value, it's 0. All right, cool. Last problem. Oh, sorry, the 2 points for this were 1 for using L'Hopital's and 1 for the answer. So you had to recognize that this was a L'Hopital problem. All right, cool. Part C. So we could have seen this coming from the beginning. This is the one that's going to be worth most of the points. This is a separable differential equation. It has no x's, therefore it's separable. Part C wants us to solve. So since there are no x's, I'm going to divide this 1 minus y over, multiply the dx over, and now I've separated my variables. On any question where you're asked to solve the diffie-q, if you do not separate the variables, you get 0 points. The AP graders have been instructed that if you fail to do this step, it's over. It doesn't matter if you do the most awesome things in the world. If you like cure world hunger in your free response solution, nobody's gonna care if you didn't separate the variables, which is sad but true. So please, 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 please separate the variables because the AP readers stop reading if you don't do this step. Okay, so once I separate the variables, right, that's super important. So separate the variables, right? Once you separate the variables, you're going to find the antiderivative of both sides, right? So you're going to integrate each side. So this is going to be the negative natural log of the absolute value of 1 minus y. And if you need to do u sub, you can. But if instead you recognize, oh, hey, this is a natural log because it's stuff on the bottom to the first power, but I realize that the negative in front of the y is going to mean that I need to multiply or divide by a negative, that's great. The other side is going to be an x plus a constant. I would suggest that you leave your constant on the x side only. Oh, also worth noting, at the start of C, they gave you the y equals f of x direction. That's code for solve for y, right? So this means solve for y. That's what that code is always going to mean. So I'm going to need to solve this. It's up to you when you choose to actually find C. Me personally, I usually do some solving before I find C. So first thing I'm going to do is, so this is my general solution, right? But I'm going to do some solving before I find C. You don't have to. If you look at the AP guide, you'll find they do it a little bit different than I do sometimes, and that's absolutely fine as long as we're both right. So I'm going to go ahead and divide by the negative, so natural log of the absolute value of 1 minus y equals a negative x, and I'm just going to go ahead and call it C sub 1 because I don't care that I divided C by a negative. I don't know what the sign on the original C was anyway. It could have been a negative 57. It could have been a 508. I don't know. So I just call it C sub 1. And then I'm going to exponentiate to get rid of all this nonsense. So I'm going to get 1 minus y equals, and then I recognize that e to the C sub 1 is just a new constant. So I'm going to call this C sub 2 e to the negative x, right? And you don't have to do that, but that's what I'm going to do. The AP didn't do it here. It doesn't matter. It's okay. And then I'm going to go ahead and solve. So I'm going to get negative y equals C sub 2 e to the negative x minus 1. And then I'm divide everybody by negative. I'm going to get y equals I'm going to go ahead and, when I divide by a negative, just call this c sub 3 e to the negative x plus a 1, right? So that's what I'm going to do, and you could do, sorry, it got a little squiffy. That's what I'm going to do, but you could do it a little differently, that's fine. So once I get here, right, I have this nice general solution where I have lazily just kept renaming my c every time it changed, so I didn't have to do anything else. So I'm going to go back up, and I'm going to use the initial condition for my solution, and I'll show you what the AP has too. Their answer is slightly different, but it comes out to be the same answer. So we have this general solution, c sub 3 e to the negative x plus a 1, right? And we know the initial condition f of 1 is 0. So 0 equals c sub 3 e to the negative 1 plus 1. Negative 1 over e to the negative 1 equals c sub 3. So I end up getting a negative e to the first equals my c sub 3. And when your c ends up being a multiple of e, it's often worth cleaning it up, but it's up to you. So I could leave my answer as y equals a negative e times an e to the negative x plus a 1, and that's fine. This is the answer I might have left it with. When your c turns out to be a multiple of e, it is very often worth cleaning it up a little. The AP chose to recognize that you could leave this as a negative 1 times an e to the first, right? And then you could combine the e to the first with the e to the negative x. So the AP's answer was a 1, they put this guy at the front, minus this 1 that you just have the minus, e to the 1 minus x, because you had a 1 and then a negative x, and that was their answer, and that's also totally fine, right? The nice thing about APs is that the people grading them are AP teachers, and they're smart enough to know if two answers are the same answer. So if there's no justifiable reason that your answer is different, but your answer is mathematically correct, they should be able to spot that, even if it's not something that's exactly in the answer key. So this was worth 5 points. On a free response, if you are asked to solve a Diffie-Q, it is probably worth 5 to 6 points, which is an insane amount of points, because it means that if you completely biff this part of the question, you are in a little bit of trouble, right? So let's go through the 5 points real quickly. Separation of variables, right? We saw that we had to move the 1 minus y over. Okay, we did that. Finding the two antiderivatives is worth a point. So 1 point for separation of variables, 1 for the two antiderivatives together, 1 for remembering that you needed a plus c. Just writing a plus c got you a point. 1 for using the initial condition, and 1 for solving for y. So if you had solved for y up to here, but then had forgotten to plug in to find c, you would have gotten 1 point off, so you would have gotten 4 out of 5. If you had solved for y like I did originally, but if you had not solved for y, but you plugged in to find c, then you would have gotten 4 out of 5 because you forgot to solve for y. So that's sort of the